Before starting with example 1.3, I want to explain what the term equivalence means in engineering economics. So you have this diagram on slide 1-9 that I will be recreating in my notes. So for your reference, I'm just going to note down that this is from slide 1-9. Okay, so let's draw the diagram here. My straight line, and then right in the middle, well, we have 3 marks here. Right in the middle we have year 0 denoted with now, then we have 1 year and year -1. Okay, then they point out that there's an interest rate of 6% per year. Okay, so this right here, the interest rate of 6% per year, is what it's going to make all the difference. Okay, so let's say that we have $100 today. If you get those $100 and you hide them under your mattress, next year you're still gonna have the same $100. But if you go to the bank and you deposit those $100 in a savings account or in a CD, or you invest them somewhere else, next year chances are that you're going to have more money than what you have right now. Okay, that's how interest works. So let's go to our formula with the end amount and the original amount. So we know that the end amount, okay, is equal to the original amount plus the original amount times the interest rate. Okay, so if we have $100 now, we can use the formula, or that same formula, to find how much money we're gonna have 1 year from now. Okay. And how do we do that? Well, if you look at the diagram, you're gonna see that year 0 is now, and 1 year after, that means that you're looking for an amount in the future. So we are in fact looking for the end amount. So let's plug in the values into the formula. So we have the end amount will be equal to 100 plus 100 times 6%, which is 0.06. This will give us a total of $106 1 year later. So that's where the 106 is coming from. You can use the same formula to go back in time. So same thing, if we have $100 now, but now we want to find out how much money this was worth last year. Okay. Then again, we use the same formula, but we're gonna need to make an adjustment here, because if you go and look at the diagram, you're gonna see the 100 are, yes, in year 0 now, but we are looking for the amount 1 year before. So these 100 actually become the end amount, and we're gonna be looking for the original amount. So we're gonna put 100 equal, and I'm going to use a factored out version because it's easier, equal to the original amount times 1 plus 0.06. And we need to solve for the original amount. So the original amount, it will be equal to 100 divided by 1.06, giving us a total of $94.34. And again, this right here will be the amount 1 year from now. Okay, so the equivalence means that these 94.34 are equal to 100, are equal to 106 at 6% per year interest rate. So that's what makes the whole difference, the interest rate or the time value of money. Okay, so now with this in mind, we're gonna start example 1.3. AC Delco makes auto batteries available to GM through privately owned distributorships. In general, batteries are stored throughout the year, and the 5% cost increase is added each year to cover the inventory carrying charge for the distributorship owner. Assume you own the City Center Delco facility. Make the calculations necessary to show which of the following statements are true and which are false about the battery costs. And then we have 5 statements or 5 cases. The first part of the problem, the first paragraph, it's actually more of the story, but you're gonna see that here you have a percentage. So it says that a 5% cost increase is added each year. So this one right here, well, let me leave it as yellow, it's actually going to be your interest rate. Okay, and we go back and note our formula and put it here, that the end amount is equal to the original amount times 1 plus the interest rate. This is a factored out version. Okay, so let's look at case A. The amount of $98 now is equivalent to a cost of $105.60 1 year from now. Okay, so we need to identify which one's the end and which one's the original. Hint, most of the time, and I'm saying most because it's not always true, but most of the time the end amount will be higher than the original amount. Okay, so, and also you can look at the timeline here. So you start with 98 and then you jump 1 year after, so then now will be the original and the 105 will be the end amount. Okay, so for part A, we want to know if the end amount, which is the 105.60, we want to know if it's equal to 98 times 1 plus, and we said that the interest rate is 5%, so it's going to be 0.05. So it's a 105.60, and if you do the math, 98 times 1.05, you will actually get 102.90. So this right here is not true. Write down that this statement is false. Okay. So now let's go to statement B. A truck battery cost of $200 1 year ago is equivalent to 205 now. So again, even though it says now, you're going to see that this happened 1 year ago, so therefore the 200 are the original and the now is the end. So part B, we want to know if $205 are the same as 200 multiplied by 1.05. So if you multiply this, you will actually get 210. So this statement is not true either. Okay, so now let's go to part C. Part C, a $38 cost now is equivalent to $39.90 1 year from now. Okay, so in this case, the 38, and 1 year from now, so 38 will be the original, and this right here will be the end, the 39.90. So we want to know for part C if 39.90 is equal to 38 times 1.05. Okay, so if we do the math, 38 times 1.05 is also 39.90. So this statement right here is true. We have part D. A $3,000 cost now is equivalent to $2,887.14 1 year ago. So you see that this is in the past and this is the future. So therefore, this one right here is the end and this is the original amount. So for part D, we have 3,000 and we want to know if it's equal to 2,887.14 times 1.05. If we multiply this, you will get 3,031.50, making this statement also false. Now we have part E, which is a little bit different because they're asking, or they're telling us that the carrying charge accumulated in 1 year on an investment of $2,000 worth of batteries is 100. Okay, so in this case, what we have is the investment. So the initial investment will be your original amount, but they're actually not giving us an end amount. We're telling us that the charge accumulated. So therefore, these 100 are actually your interest. Okay, so it's the interest accumulated or the interest accrued. Okay, so if you remember from the formulas, okay, we have, what do we have here? We are given here at the top the interest rate, okay, which is 5%. We have the original amount and we have the interest accrued. So if we go back to the formulas, we're going to see that this one right here has the interest rate, it has the interest accumulated, and it has the original amount. So we will be using this formula from slide 1-5. And so if we write it down here, that the interest rate, I'm just going to put it as a reference, that it's the percentage, is equal to the interest in terms of money divided by the original amount times 100. Okay, so we want to know if the interest rate, and here we do put it as a percentage, this is the given one. We want to know if this is equal to 100, okay, given here, divided by the original, also given, times 100%. Okay, and if we solve this, 5%, it's actually equal to 5%. So this last statement is also true.